In this video, we will find the distance between 2 points on a line parallel to the coordinate axes. To begin with, let us consider a two-dimensional Cartesian coordinate system as shown here. The most common names of the coordinate axes are x-axis and y-axis in this system, so let us label those as well. We need to consider 2 points in this system, and further we will try to find the distance between them. We can have infinitely many possibilities here. But for the purpose of this video, let us consider these 2 points to be on a line parallel to the coordinate axes, that is, either parallel to the x-axis or parallel to the y-axis as shown in these figures. But the possibilities don't really end here, do they? Those points can either be on the axes in any one of the 4 quadrants, or maybe one point is in one quadrant while another one is in one of the adjacent quadrants. I mean, even in this case, the line is clearly parallel to one of the coordinate axes, isn't it? Let us try to find the distance between the points in these particular cases. In the first case, we can clearly see a couple of things right off the bat. Firstly, the line is on the x-axis, which in other words means the line is parallel to the x-axis, as a line is always parallel to itself. Another point to notice is that the blue point is -4, 0 and the purple point is 2, 0. Let us name them A and B respectively. Notice there is no difference in the y coordinates, as you can see here. This is due to the fact that the line is parallel to x-axis and thus the y coordinate remains constant. Now, what will be the distance between these 2 points? We can count and arrive at the conclusion that the distance between them will be 1, 2, 3, 4, 5 and 6 units, isn't it? But it is not natural that we will always be able to plot a graph, so naturally we should wonder if there is an easier and faster way to arrive at this conclusion. Notice the coordinates and try to find out if we can somehow arrive at 6 units or the number 6 from here. Well, if we add -4 and 2, we will get -2, which is not what we need. But if we subtract 2 from -4, we get -6, looking at which it seems like we are close to our answer, but distance can never be negative. So we need to further think about this. What if we reverse the order in which this subtraction is being performed? What will we get? We will get 6, which is indeed our answer. But how do we decide the order in which we need to perform this subtraction? To tackle this issue, mathematicians came up with something called modulus of a number. You will be studying a formal definition of this in higher grades, but for now, we need to know 2 things. Firstly, the modulus of a number, let's take -6 or -6, is denoted by modulus of -6. This is how we read it. Secondly, and most importantly, modulus always returns a non-negative value of the same magnitude. Thus, the modulus of -6 cannot be -6 but rather of the opposite sign, so it will be +6 or simply 6. Note that the modulus of 0 is 0 itself, since 0 is non-negative, and modulus of positive or +6 will be 6. Symbolically, if we take 2 points on a line parallel to x-axis, say x1, y and x2, y, then the distance between them will be x2 minus x1, but we don't know the exact values of x1 and x2, do we? Therefore, we should use modulus to make sure we will always get a non-negative value. Let us move to our second case. Here, the line is parallel to y-axis. I highly encourage you to pause the video and try to come up with the observations that we made in our first case and find the distance between A and B. Did you come up with these observations? If so, well done, you're paying a lot of attention. In case you're wondering, symbolically, if we take 2 points on a line parallel to the y-axis, say x, y1 and x, y2, then the distance between them will be y2 minus y1. But again, we don't know the exact values of y1 and y2. Therefore, we should use modulus to make sure we always get a non-negative value. If you have followed the concepts so far, you should be able to find the distance between the points given in our third and final case. I'll leave this as an exercise for you with a hint that this case is very similar to our first case. So in this video, we tried to make sense of why modulus out of all the things, that too modulus of difference of coordinates, works really well to find distance between 2 points on a line that is parallel to the coordinate axes.